These are your integrated math 2.2.2 notes. Please write down the topic is right triangle trigonometry. Please write down the learning targets. Target number 1, given one angle of reference and one side length of right triangle, I can use the tangent ratio to find missing side length. Learning target number 2, given two side lengths of a right triangle, I can use the inverse tangent ratio, also known as the arctan, to determine the measure of an acute angle within a right triangle. So you need more time to write this down. Just pause the video now because I'm going to go to the next slide. First example. All right, example number 1. We know SOHCAHTOA, TOA, for identifying which trig ratio we want to use. So on this one, our angle of reference is 23 degrees. It's our acute angle within the right triangle. That's our angle of reference. I put my thumb on the angle of reference. I know the side I'm not touching is our opposite side. I know that's the hypotenuse. And when I put my finger on the angle of reference, I'm touching both the hypotenuse and the adjacent leg. So this will be the adjacent leg. So TOA is when we're using opposite and adjacent. And we know that T represents the tangent ratio. So tangent is opposite over adjacent. So let's go ahead and write the trig equation. We're going to say the tangent of 23 degrees equals 14 over D. Then we're going to go ahead and convert the tangent of 23 to a decimal number. Make sure your calculator is in degree mode. You know you can use Desmos online. We've done that in class. Let's take a look. So I'm going to go tan 23, and I'll write to the nearest 10,000th. So that's 4 decimal places in. So I'm going to go 0.424, I round up the last one to 5, equals 14 over D. So now there's 2 ways you can solve this. Well, first, we'd like you to think of it as just an algebraic equation. All right, I want to solve for D. So if I want to solve for D, the first thing I would do is I would multiply both sides by D. So when you do that, we have D over D on the right side. We go to 1, so it would be 14 on the right. And the left side would be 0.4245D. And we'd solve from there. I'm going to show you another way we could do this. We've been doing a lot of work with proportions recently. So I can put this over 1. I have a proportion now. We just do our cross multiplication. So I cross multiply here. I get 0.4245D equals 1 times the 14, which is 14. So whether I do a proportion or if I do it algebraically and I multiply both sides by D, I get to this point right here. So now, how do I solve this? Well, I want 1D, so I'm going to divide by 0.4245. What you do to one side, you must do to the other. 0.4245. All right, so I'm going to use my handy dandy calculator because I don't know that off the top of my head. I can give you a ballpark, but 14 divided by 0.4245, and I'm going to get the answer is the distance is 32.98, where the units of measurement is. I didn't give you meters or anything here, but that's the length of it, 32.98 units. All right, so that's just solving for a missing side using the tangent ratio. Next example is using the inverse tangent, also known as the arctan. And in this case, we're trying to find a missing angle measure, but we're given 2 side lengths. So again, this is my angle of reference. We know that this is the opposite side, and then this is the adjacent side, right? Finger on the angle of reference, not touching the opposite. I'm touching the hypotenuse and the adjacent. Here's the adjacent, right? Hypotenuse is across from the right angle. All right, so SOHCAHTOA, we know we want to use the tangent ratio. So we're going to say the tangent, and this I can just say tangent of angle F, because we don't know what it is, equals this ratio, 18 over 15. All right, so So then I'm going to convert 18 over 15 to a decimal number. So I'm going to go 18 divided by 15. And I get the tangent of angle F equals 1.2. In this case, it's 0, 0, 0. So I don't have to write those zeros, but I want you to remember, go to the nearest 10,000th place with your decimal for the trig. All right. So now, I don't want to put tan 1.2 in my calculator. Why? Well, if I put tan 1.2, what I'm telling the calculator is my angle of reference is 1.2 degrees. Tell me what the trig ratio is, what the tangent ratio is. That's not what we want. We know the tangent ratio is 18 to 15 or 1.2 to 1. We already know that. What we want to know is what is the angle of reference? What's the measure of it? So to tell the calculator that, we're going to use what's called the inverse tangent. So this is what I want to see when you do your work. I want you to say measure of angle F equals inverse tan of 1.2. All right. Now, depending on your calculator, we will go to second on my calculator, tan. I put in the 1.2. Make sure you're in degree mode, and it spits out the answer. So measure of angle F equals 50.2 degrees. Again, if we did it on Desmos, this is where we would go to where it says functions. We click on the functions, we'd see this symbol, click on it, and use it on the calculator online. All right, now does that make sense? So 50.2 degrees, that means this angle is bigger than this angle, right? Because these two have to add up to 90. This would be what, 39.8 degrees? So, yeah, this is a bigger side, bigger angle, bigger side, smallest angle, smallest side. Obviously the right angle is the largest angle, and that hypotenuse is always the largest side, right? So that does make sense, it does work. So that's how you find a missing angle. We will be doing this for sine and cosine as well.